So hello everyone, and welcome to the second in the web series webinar of for sustainability hosted by Basis. It's got a delay. The topic for this month is sustainable soils. So thanks again for joining us today, and I hope you all enjoy the webinar. So just before I start, I'm just going to do some housekeeping. So firstly, I know some of you will have had to join kind of anonymously if you've not got a Microsoft account. That's absolutely fine. The only thing I'll ask you to do is if you had to join anonymously, then please put your 200 number into the Q&A box. Then we can record all that, and then your the CPD point that's awarded for this webinar will be allocated to your account afterwards. And the Q&A box is also where you can put questions. So what we're going to do is we've got myself and two speakers today. So we will be able to have a panel session at the end, actually. So we're not going to answer questions at the end of each section. I'll keep note of all the questions that are being asked throughout, and then we'll try and see how much time we've got. We'll pick out some of the key questions and put them to our speakers today, or I might be able to answer them myself. The other thing is, if anyone's having any technical issues, or if I have any technical issues and no one can hear me, or you lose the presentations or anything like that, please just drop that into the Q&A, and then I'll be able to pick it up from there. So let's make a start. So firstly, I just wanted to talk about why are we doing this today? Why are we talking about soils? Why are soils so important? And there's lots of reasons really, and we hear about it so much in the press. But the first thing that I always like to focus on these topics is food and food production, and it's what we all do, and it's what we're all involved in, whether we're advisors or growers, whoever works in this industry. Our aim is to produce safe and sustainable and healthy food. And 95% of all the food that we produce globally is directly or indirectly produced from soil. So when we say indirectly, we mean livestock production from grass pastures and things like that. So at the end of the day, we need soil to produce the food that we need. The other thing that soils do is they're such a fantastic management of flooding and water, and that the number there is 130 trillion litres of water. That's just a huge amount, impossible to imagine, that's kind of held in UK soils. What I thought was really interesting was that's more than all of the rivers and lakes in the UK combined, and it just shows you how that is helping managing the flow of water and managing flooding risk throughout the UK. So yeah, that's a really interesting bit I didn't realise kind of soil provided for us. And finally, this is something that's becoming way more poignant at the minute and is in the farming press a lot, and so much of the legislation that's going to affect farming in the future is going to be aimed around this, and that's soil carbon, and how soil can act as a carbon sink for us, storing the carbon dioxide that's in the air. And as we try and move towards net zero agriculture as the NFU want by 2040, soils are going to play such a huge part of this. But we all seem to be really worried about soil health. There's so much in the news. Why are we so worried about it? Why are we so keen to improve the health of our soils? Firstly, is because we're losing them. 84% of the fertile topsoil has been lost over the last 170 years or so, and it's continuing to be lost. And it's at the minute, it's not an endless supply and not an unlimited resource. So that's why we're worried about it, because it seems to be disappearing. The other is the cost, and you always see these kind of numbers from a lot of kind of government guidance and government research, and the cost of soil degradation is £1.4 billion a year, and that comes from a huge number of different factors. So that's through carbon release and the effect on climate change. It's from a reduction in production. It's from increased effects of flooding. So that's another reason is the economics. And the final one is obviously greenhouse gas emissions and the loss of organic carbon. Kind of soils have the huge potential, because they hold so much carbon, there's so much potential to act as carbon sinks or carbon sources. And actually, if we can increase the organic matter in our soils, or the amount of soil, they can act as such a massive carbon sink, which will have such a significant impact on greenhouse gas emissions and climate change in the future. And finally, this is just an image I took from, this was from the United Nations website, and it kind of tries to show all the ecosystem services that soil provides to us. And I know that's something else that kind of government and organisations like the UN are so keen on, is ecosystem services. And there's some really interesting ones in here, some that are probably less relevant to agriculture when we look at the construction materials and the heritage, but some of the things like nutrient cycling, climate regulation, and water purification, and also things like flood management, all provided by soils. And these are the kind of things that farmers are going to get supported and paid for in the future. If we can help reduce the impacts of climate change by managing our soils correctly, reduce the risk of flooding, help maintain that biodiversity, which, as it says at the bottom, is a source for kind of pharmaceuticals, things like that. And finally, one of the, it seems quite a small segment to me, but the provision of food, fibre and fuel is obviously such an important thing, and I think I'd quite like that to be a bigger segment, really. But yeah, so like I say, this is the second in our sustainability series of webinars that we're running at BASIS. We had the sustainable crop protection one last month, and the video for that is available on the BASIS YouTube channel if you'd like to go back and look at that. Sustainable soils, which is what we're covering today. And then in January and February, we're going to have two more webinars, one looking at sustainable storage, and that's going to be of both fertilizers, manures and pesticides. And finally, we're going to look at a bit more broadly at sustainable agriculture, specifically looking at kind of carbon capture and net zero agriculture by 2040. So finally, I'd like to just tell you what's coming up today, and then I'll pass on to our speakers. So firstly, we've got Iain Gould, who works at the University of Lincoln, and he's going to look at the science of soils, organic matter and carbon. Iain's going to then pass over to Phil Jarvis, who works for GWCT at the Allerton Project, and he's going to really look at the practical side of soil management and how we take that science that Iain's going to talk about and actually utilise it and make changes on farm. And then finally, you've got me again at the end, who's going to talk about kind of how the role BASIS plays in this and how we try and promote sustainable soil management, specifically through our qualifications. So I'm going to pass over to Iain now. Hopefully he'll be able to, this is where the technicalities coming in. Hopefully Iain's going to be able to share his screen and his presentation for you all to see. And then I'll pass over to Iain.
So can you see that one slide? Greg, can you see the slide?
I can see the slide, yep.
Fantastic. I guess that means it must be working. Brilliant. Thanks, Greg. Thanks for that great introduction on soils. I think you covered the reason why I'm in the business, really, why I got into soils. I'm a soil scientist at the University of Lincoln, and part of my time is doing research, and other parts of my time, the rest of my time, is delivering soils courses. So working with the team here, with Simon Goodyear, delivering soils courses, soils basis courses as well, and other undergraduate, postgraduate courses. My contact details on that slide, and you can always tweet me if you're that way inclined. What am I going to talk about? Well, as Greg said, I'm going to kind of come from the science perspective, talk about a little bit about the theory. Let's say, yeah, we'll use the term theory lightly, but we'll talk about the science behind how we build organic matter and also carbon in soils. So we're going to be talking about their role in the carbon cycle, and then look at organic matter, how we build it up, and the inputs and outputs. So how do we lose it as well? At the end, a little exercise in how much could we actually, what does that actually mean? Building organic matter, what does that mean for carbon sequestration? So let's start with the carbon cycle. So this is why carbon is increasingly more important on the agenda, both politically, internationally. We turn on the news, everything's net zero. Different countries are trying to move towards net zero at increasing rates. So carbon's really important. And when we talk about carbon, when you switch it on the news, a lot of the focus on atmospheric carbon, the CO2, which is that real critical greenhouse gas. There are other greenhouse gases that we're familiar with, but a lot of the focus is on atmospheric carbon. We know atmospheric carbon. I've actually put the size of the pool of atmospheric carbon. It's roughly just shy of 800 gigatons, which is 800 billion tons. It's a lot. But we know that carbon's also fixed by vegetation. So there's another pool of carbon, which is the vegetation. We know that's fixed by photosynthesis. However, we also, and Greg alluded to this earlier, we also have a really significant carbon pool in the soil. And what I always find fascinating is that the soil holds more carbon than vegetation and the atmosphere combined. So it's a real important player in the carbon cycle. It's really important because it could be a sink of carbon. Carbon can get pumped into the soil and potentially stay there for a while. But also, and historically we've seen this, it can be a source of carbon. It can be a release of carbon back up into the atmosphere where maybe we don't want it. What we're really going to focus on in this talk is that soil carbon, that pool at the end there. How do we get the carbon into that soil and try and keep it to stay there? When we talk about soil carbon, well, most people talk about soil carbon, we probably all refer to it from in the wider context in terms of soil organic matter. Now, organic matter is not all carbon, but a large proportion of it is, roughly 60%, we'd say, give or take, depending on what the composition or the original material is, but roughly 58% carbon, soil organic matter. So, and when we talk about soil organic matter, personally, I find I'm a bit more comfortable. It's something we know a bit more about and we can refer to a bit. We're a bit more comfortable using the term soil organic matter because we know about the benefits of organic matter in our soils. Here's a classic. This is a couple of trial pits we dug, or some samples we dug a couple of years ago, actually, this slide, where we did the classic dig in the hedgerow, dig in the middle of the field, have a look at the soils. And what you can see here is certainly a colour change. We've got a soil from the hedgerow, which is a lot darker in colour and has a lot more organic matter. And what that organic matter does is it gives us all these fantastic benefits. It builds a darker colour, which might link to how soils can warm quicker, potentially getting a bit of an increased season there. Much structural benefits in terms of soil aggregation, water retention and water infiltration. So the very relationship that soil has with water can be improved by increasing organic matter content. Again, there's a big link to our relationship with nutrients. It's got a high cation exchange capacity. Some people run away from the word, but if you remember if you've done facts or perhaps soil and water, you might be familiar with that. And that's how many nutrients basically the soil can hold, or cations. But it also has a role in releasing nutrients, because if we think back to our nitrogen cycle, again, from something like fact, if you've done fact, mineralization, we can get organic nitrogen or organic phosphorus can be locked up a bit or immobilized in organic matter, but slowly can be released by the role of microorganisms. And also, ultimately, organic matter can help build our workability. So organic matter is this fantastic medium that gives us better properties in agricultural soils. However, it's also a carbon store. So it's a bit of a win-win, you could say. So how can we build it in soils? We've got to really look at the kind of the process of how it's built up in soil. So here's my artist's impression of a soil. You've got the soil, you've got the atmosphere. How it starts, well, organic material, whether that be plant residues or organic amendments from offsite, gets put into the soil. So either by incorporation or left residues at the surface, or ideally being put really into the soil by the action of roots. So our organic matter journey starts off with organic material in the soil. And it is a bit of a journey, because there's no set kind of categories of organic matter in soil so much. It's more of a gradual process from a very active organic matter, organic carbon, to a much more stable organic carbon. Now, an active organic carbon is it's decomposing. It might be in the soil for days, weeks, months. And as it's decomposing, it's releasing a lot of CO2. So there are losses of carbon there. But gradually, our carbon can move down as we move on with time to a more stable carbon pool. The active pool does release nutrients. It's really good. It's got a bit of mineralization action going on there. So we're getting nitrogen and phosphorus potentially from it that's not available. But our stable carbon pool, that black pool at the end there, that's sticking in the soil for a bit longer. That's giving us those benefits like structure, cation exchange, and making the color a lot darker. And there are losses from that pool. There are some losses, but not as much as in our active pool. So gradually, the more organic material we can put in, it might slowly get towards that stable pool at the end. That's our end goal. If we can get the carbon into that stable pool, yes, we can lose it, particularly if the system is disrupted. But if we can just try and improve that journey as best possible, That's a great way of getting more stable carbon in our soils. That's a bit of a schematic there, but let's look at that actually in practice. How do we do that? Okay, so realistically, if we want to get further towards that end pool, we've got to look at our inputs and our outputs. So let's think about where the inputs come from. Well, they're from the plant, it's from the organic carbon there, but also from different organic amendments that might come out the back of an animal. So we look at our inputs, we're also got to focus on our losses. Key losses of carbon from a system are going to be via oxidation, and we're going to focus on that quite a bit later, and also on erosion and leaching. Now, many of you might be a bit more familiar with erosion and leaching because it's how we lose nutrients or soils in other aspects of soils and agriculture. Oxidation we're going to focus a bit more on because it might be a bit of a new thing, and it's certainly a bit more of an emerging field of where we need to be looking at in terms of carbon storage. So let's start with inputs, okay? And we're going to look at two types of inputs. We've got our crop, that's our carbon input to that soil, and then we've got off-site inputs as well. So let's have a look at our crop. So here's our crop, artist's impression. Not a very good one, I'm afraid. That's from me. So let's have a look at the carbon inputs from the crop. So if we grow a crop, that's fixing carbon from the atmosphere by photosynthesis. So we're already, by just having that crop growing, we've got carbon and we've taken out the atmosphere, maybe where we don't want it, and we've put it in the plant where it's not causing global warming. But that plant isn't always going to stay as it is. It has a life cycle, and we use parts of it. So let's have a look at the different pools of carbon in the crop. So the first pool of carbon will be the roots. Now, as the crop is harvested, those roots, generally speaking, could stay in the soil, would stay in, depending on what part you're harvesting. We'll look at a cereal, for example. That carbon's really well placed in the soil. So it's already starting its life in the soil. And so when it starts to decompose, there tends to be, I mean, you lose about 2/3 of it via decomposition. We'll look at that decomposition later. But we're losing about 2/3 of it, but the rest of it is then allowed to start to build that organic matter. So roots are quite a really nice way of building carbon. The more roots, the better, you'd say. As we move up the plant, the next pool of carbon, if you will, is our, let's call it the bit we're not harvesting so much. Our residues. So this is kind of the optional extra. Do we return these to the ground, or do we have a use for them elsewhere? This is a bit more of a complex story, right? So we have our residues. That's the next part of carbon. If you do return them to the soil surface, you tend to lose a little bit more by decomposition. So a little bit less of that carbon is ending up in our end goal of stable organic matter, but it is still input into our stable organic matter. It's not as effective or efficient carbon cycling as roots because it's usually incorporated at the surface. Maybe incorporation is not as rapid. And our third pool of carbon is the grain. That's the bit actually we want to go off-site because that's where the bit we'll sell. Potentially, we might harvest other parts of the plants as well, but in general, that bit's going off-site. So that's carbon that's lost from the system. Of course, it might end up coming back into the system via different ways, and I won't go into the biology of that. But in a sense, the more crops we grow, there are different pools of the crop that can have more or less potential to build soil organic matter. That's the crop. What about from elsewhere? And I would urge anyone who's interested in this to check out this report from a few years ago, the RAP DC Agri stuff, which was done by a range of researchers in the field. And it looked at sort of longer term applications of organic amendments to soils and how they build up soil organic matter. And they found that compost is a really effective builder of soil organic matter. Farmyard manure is also a good builder of soil organic matter, but compost particularly so. And that's because actually it's already composted. It's lost a lot of its CO2 at the compost facility where it's been composted. But by the time it's incorporated into soil, it's more of that stable stuff that's sticking around for a bit longer. So I would urge anyone, if they're interested in this side of things, to check out that report. So those are the two of the inputs I've really focused on today. Let's have a look at some of the losses. We go back to our diagram of how we build organic matter. You can clearly see our losses come at different stages, but we're losing it. A particular loss we're going to focus on here is our respiration, our CO2. There are other losses. We're going to focus on these two just this morning. So how can we reduce potentially this loss of carbon from the system? Well, we've got to look at how it's lost. And it is lost by the action, and we want microorganisms in the soil, but it is lost by the action of microorganisms as they decompose organic matter. They use organic matter as a food source. Same reason we have food sources. In the presence of oxygen, they break that organic matter down to form energy and essential nutrients. But in doing that, and part of that, nutrients are essential for nutrient cycling in the soil and linked to a lot of our processes with the nitrogen and phosphorus cycle. They get themselves energy. However, the villain of the piece is they're also, as a byproduct, producing CO2. So could we explore ways of trying to minimize that CO2 loss? Well, the two ways really are to focus on how microorganisms can attack that organic matter. Although I must stress, we want microorganisms in the soil, we just don't want an imbalance of the system. But also, what about the oxygen? Is there a way that you could address these two areas to kind of potentially reduce losses from the system? Let's first focus on oxidation. Well, aeration is really essential for soils to function. So we really want oxygen in the soil, but a shift too much of a disturbance, too much of a release of oxygen into the soil could kind of speed up that decomposition process a bit too much, and we might release a bit too much CO2. But it is one of the thought processes, the theories behind that the movement towards reduced soil disturbance, reduced tillage. If you've got reduced tillage, you tend to disturb that soil surface a bit less and lead to less kind of oxidation of that organic matter. But we must stress aeration is important for soils. And the microbes as well, what about their role in this? They break down organic matter, but they are essential in soils for so many reasons, particularly nutrient cycling, and that comes from that breakdown of organic matter. But what we probably don't want is a big increase in breakdown or a shift to the system that speeds things up. So what can we look at here? What kind of soil management might help this kind of slow this down to a more gentle pace if we had a rapid oxidation going on? Well, we know that soil organic matter can be protected from the microbes, either physically or chemically. Another artist's impression is as the microorganisms break down organic matter, forming that process, is there a way of physically protecting organic matter? And this is when we get into it. You might have heard of stuff like mineral associated organic matter. When the organic matter is physically protected so the microbes can't get at it, that's when carbon, organic matter, is really protected, really locked in. How might you do that? Well, it is really determined by stuff like soil type, but also improving structure. If you've got a better structure, you've probably got more protection of that organic matter, and you've got a more complex environment where it can be kind of stored. It can help glue soils together, and it can be kind of stuck between clay colloids, soil minerals. But if we break down our structure, we might expose that carbon to microbial degradation again. Here's an example of that. Some of you might have heard of the slake test. I did a video of this, but I didn't want to hazard showing a video on here with my internet connection, so I've just done a couple of screenshots. So this is a slake test. I've got two aggregates. They're of the same size-ish, from two different fields. One we actually know has got better structure than the other. We drop them in soil and we wait a couple of minutes. 2 minutes later, we go from one to the next. You'll see that bottom aggregate it's slaked, it's broken down, the structure's not there anymore. The soil's broken down. And what that can do is actually expose organic matter, expose carbon to that microbial degradation. It could lead to more of a release of CO2 and less protection of organic matter. So better structure, the better. If we can improve those structures, we can help kind of sequester more carbon or more organic matter. These are two kind of interchangeable. This also links to texture, actually. If you think about sandy soils and clay soils tend to be able to hold much more carbon, because if you look at these images, clay soils are much more complex, lots of microenvironments there where that carbon could be kind of locked in, like trapped, occluded from microbial degradation. Sandy soils, they've got big, sparse, say big, but large spaces in them, gaps full of air, with a lot of aeration, a lot of oxidation, so they tend to not be able to hold as much carbon or organic matter. And that rings true in practice if you do organic matter tests in a clay soil versus a sandy soil. So that's very much a kind of whistle-stop tour of some of the theory behind how you can sequester more carbon. But what is interesting, I think, for us all is to, and I'm not a modeler, I would say I'm a digger, I dig things, I don't do so much modeling. So my soil is very much field-based, but you could roughly look at organic matter sequestration in soils and link it to how much carbon there is, or how much carbon dioxide equivalent there is. I've put the animations wrong on there, but in 1 tonne of soil, let's say 1 tonne of soil, we build soil organic matter from 3% to 4%. How much carbon dioxide equivalent is that building? Because if we talk about carbon dioxide equivalent, you can start to relate this to offsetting carbon. So if soil organic matter is around 58% carbon, as we go from 3% to 4% soil organic matter, we're getting an increase of 5.8 kilograms of carbon per tonne of soil. I wouldn't worry about the maths here. If you do want to go through the maths here, drop me an email. I'm happy to chat about these, or contact me on Twitter. But roughly, if we go from a sort of a 1% increase in organic matter per tonne of soil, you're getting about 5.8 kilograms of carbon. But that's just carbon, not carbon dioxide equivalent. You can do a bit of a fancy conversion to carbon dioxide equivalent, but in essence, you multiply by 44 as well. But it's not that fancy, but in essence, 5.8 kilograms of carbon is about 21.3 kilograms of CO2. Why have I done this maths? Well, if you think about it, that means that 1 tonne of soil going from 3 to 4% organic matter captures an extra 21 kilograms of CO2. And maybe we could look at that in terms of other users of CO2. So where would that be on a flight? If I bought an economy flight to New York, 21 kilograms of CO2, where would that get me? Well, it might not get me that far. It'll probably get me to about Bristol or maybe Cardiff. It's about 1/40th of the journey. However, that means that 40 tonnes of soil, if you increase your organic matter by 1%, that's going to lock up enough CO2. This is this is only from my Googling of what a flight is, to fly economy from London to New York. That sounds like not a lot, really. 40 tonnes and you're only getting a flight from London to New York. But 40 tonnes is actually a lot of soil. If you look at it on a map, this is our field at the university farm. Within that box there, that's 40 tonnes of topsoil. We've gone it to 25 centimetres. So in that box there of soil, if you can increase organic matter there by 1%, that's an economy flight to New York equivalent CO2. So you imagine the whole field, and that's not even a very big field, you could it is starting to play a significant role in carbon cycling in general in soils if you're building organic matter. And I think that's a real potential positive story for agriculture. I mean, there's a lot of negativity in the news about carbon emissions in agriculture. Looking at the role of organic matter could be a nice positive story. But I must mention that every soil has a max. We can't just keep storing carbon forever. Every soil has a kind of carrying capacity. So that's really a bit of a whistle-stop tour of some of the carbon story in soils. I'd just like to say we are delivering soils courses at Lincoln. Soil and water management, the good news is we've still got places for that next year in January, and that's online. So if anybody's interested, let us know. But we also deliver quality of soils every year, which is looking more about the biology, the carbon, if you're interested in that kind of thing as well. So that's really it from me. I hope you've enjoyed that, and I'll be hanging around for questions at the end. But I believe if I stop sharing, I'd like to thank you all, and thanks for the opportunity to talk. I'll stop sharing now.
Thanks, Iain. That was fantastic, and yeah, a real insight. And like you say, we'll have questions at the end. I've already got a couple that have been sent in and noted down, so we'll wait for the questions from Phil's section as well, and then we'll have a bit of a panel session at the end. So we've got Phil joining us next. Hopefully he'll be able to. Hopefully the IT systems will work with us, and Phil will be able to share his presentation with you now. And it should come up. There we go. Magic. So I'm going to pass over to our second speaker, who's Phil Jarvis from GWCT.
Are we back on, Greg?
You're back on, Phil. Yeah, it's with you.
Yeah, okay. Sorry about that. Once my presentation was up, no, I couldn't turn my mic on. Right. Well, good afternoon. And after Iain's presentation, I'm really going to give you a look at machinery management and mindset, I've called it. And this is really an in-field guide to how we address soil management. It would be fair to say that some of this will be second nature to a lot of you, but I think it's worth revisiting the conversations we might be having, the advice we might be getting or giving people, and the advice we might want to learn for the future. So I'm just going to give you really the experiences from the Allerton Project in Leicestershire. And, you know, there's a drone shot was taken 2 or 3 months ago there. So this is quite a mixed landscape with grass, but high Leicestershire, clay soils, 30% content clay. So, you know, that affects the properties of the soil. That 2019 cropping map there was probably when we had our last planned cropping map without the weather interfering and changing it. But it gives you some idea of the crops that we're growing as well. And to give you some, and these were some pictures that were taken in the summer as well, the sort of wooded landscape nature, you know, wheat, oats and beans in a main thing in our rotation. So that
just 1 second, Phil. I think we're still on the title slide. It's not moved on my screen. Is it with you, Ian?
No, we're still on title slide.
Yeah, so sorry about that, Phil. I just wanted to stop you before you got into your flow about.
Has it moved on yet?
No, not yet.
Okay. What I might just do is I might just try and escape and unshare and share my screen again.
Yeah, that's fine. Yeah, sorry. Yeah, that's fine.
Just
we don't want everyone to miss out on the fantastic map of the Allerton Project you've got. So yeah, no, just bear with us, everyone, and we'll get Phil back up and running in a second.
Let's just try that. Is that any better?
That's it. Yeah, you got it spot on. There we go. We can see a map now. Perfect.
The wonders of technology. So I'll just recap basically. Here's the wooded mixed land on the right, and to the left is the map of our cropping. And as I said, that's when we had our last planned cropping before the weather intervened. So quite a diverse rotation, 5-6 crops in there, and heavy soil. So my experiences are going to be from there. Greg, I'm going to ask you if this has moved on.
Yeah, yep. It has done for me. Yep.
Excellent. So we're up and running again, and this is the second slide that I showed really about the landscape at the Allerton Project. Rolling landscape, high Leicestershire, spring barley and spring oats and spring wheat in these fields. Some winter beans were about the only winter crop we did have, and this is spring wheat on the field right in front of us on the left there. So that gives you an idea of what our landscape's like. And my first step really is to look at what are we dealing with, because if we go and advise or we go and look at a farm or we look at a field, really, you know, digging up the soil and putting it in your hands and texturing it unlocks a lot of things. It'll unlock the, you know, the cropping that potentially we can do, water holding, you know, the drainage requirements, and also, you know, what its potential is as regards, you know, is it going to be grass, livestock, and what are some of the traits that might go with that soil texture as regards nutrients, you know, phosphate and potassium. So really step one is, what are we dealing with? If we don't dig up and look, and if we just say, well, I see there's a cropping map from before, I always think it's best to just put something in your hand, texture it. And the one thing I would say about when people say, well, what sort of soil is it? If you've got 30% clay in your soil, you've got a clay soil. Sometimes, you know, clay plays a real heavy part in the you know, investigating your soil. So it really has a big part to play. And it's always dangerous when you do a presentation. Well, usually on Instagram or Twitter, everybody puts their best pictures on, but that's you know, we can learn as much from things when they go wrong. So let's have a look at what happens when things go wrong. So my step 2 is about ditches and drainage. And I'm going to go as far away from the field as first to start here. How many conversations do we have with growers where we ask them about what's their ditches like and what's their outfalls like? And that's a real crucial part, because if you've got water on heavy land and it's staying in the field, whatever you're going to do with the rest of your soil, you've got a problem. So ditches are key. The first port of call is, you know, get out, have a look at the drainage maps, have a look at the ditches, have a look at the outfalls, because if your outfalls aren't clear or your ditches are blocked up, it means it's really difficult then to start managing the soil, especially during wet weather. And of course, this will be different on drier soil, so on lighter soils, and sandier soils where drainage isn't a problem. You know, many of those soils won't have drains, and it'll be the reverse problem where you'll be trying to keep water in the field. But for us, making sure our ditches are clear is really key. And, blocked and broken drains as well. Here's a picture from a couple of 3 years ago of a drain that hadn't been in very many years. And this was, and you can see on the one on the right here, was just debris from hedge cutting and debris from oilseed rape roots that had caught in a junction of a 6-inch pipe. So making sure that your broken drains and making sure that your ditch management, i.e. you've got proper silt traps in front of, if you've got drains coming from one field going through another field, that's really crucial, because otherwise you end up with issues on your soil and erosion as well. So making sure your drain maintenance is up to scratch, making sure you're repairing broken drains, and really looking at how you put your drains are in a good shape. It's really, and there's some great documents around. The AHDB Field Drainage Guide is a good place to start. The principles behind mold draining, which is sort of, now we've got away from ditches to drains, and now we're talking about drainage we can actually have some influence with. So on heavier soils, putting a channel in that gets into the gravel, that gets away, means that you're keeping your potential for getting water away, which on a clay soils is really important. So step 3 really is looking at compaction as well, and looking around the countryside this autumn and possibly last autumn. We're seeing a lot of areas of ground where water is sitting, especially on headlands, and this is where we've overworked soil, or we've had heavier machinery going on, and that's really causing a problem. And of course, the other thing to remember is on all those areas as well, we're putting a lot of crop inputs in there as well, when we may not be getting the potential for return on them, but we're still spraying and perhaps putting fertilizer in them. So getting our headland and getting it right, and getting our compaction right, and the machinery is really key. So how many conversations do we have about the tyres and the pressures that are in those tyres with our farmers, or do we just say, well, that's the job of the farmer to do that? And how many times do we change them from field to road? Because that's really crucial. The more we compact those layers of soil, the less they're able to perform the job they're there for. The less water can go through them, the less worms and plant roots can get through them, and then lack of air getting in them. So it's a really crucial thing is, ditches and tyre pressures, conversations about how we deal with them. So, tyres have got a lot better in the last few, probably 5 or 6 years, with better sidewalls, and they've got massive variation in tyre pressures. But looking after soil and looking after its structure is really, really key. So compaction machinery, really attention to detail there. Now, this slide could be a whole presentation in its own, Greg, and in fact that structure, organic matter, nutrients, and pH. How do we now? We're now coming up to the surface of our soils now, where the real sharp end, where the action starts. So we're looking at either visual soil assessment or a VES score, which is a visual evaluation of soil structure, and that's basically a very quick test to look at what's the structure like right at the top where my plant is going to be growing. So I'd recommend definitely looking at in a few fields that you're going to be doing cultivations. It's really crucial. Now, Iain's dealt a lot with organic matter, and there are some organic matter. We could stray into lots of areas here on mass tests and loss of ignition tests, and we could start talking about whether or not it's probably better to do tissue testing. There's a whole host of areas that we could look at, including Iain's talked about flocculation tests and set ourselves a whole lot of targets. I think the main thing is, how do you know what your organic matter is? Are you doing a test, and are you going back to it every 4 or 5 years? I'm not sure that we've found, I think we've got some good tests out there. I'm not sure that we've got the whole system in place that tells us to the degree we need how much carbon is being stored in our soils. So very much I like to see policy reward the practices we know will help soil organic matter. So more carbon amendments, for example, or carbon additions to there from organic matter, or growing grass, or growing cover crops. Those ways that we might, incorporating straw, reducing cultivations, all those things, rewarding those practices or getting them into our system is much more likely to see that longer term increase in organic matter. And also knowing what else is in our soil, nutrients and the pH value, especially with grassland. The first thing I always say is, before you ever reseed a grass pasture, is test its pH. Is the lime level all right? So really key. But I'll leave that bit about testing just there, just to say it is step 4. It's really important to the tests down on the ground. We could, now talk a bit more about machinery now, and talking about making sure you read the instruction manual. So this is probably the most important piece of machinery, or one of them, and obviously it's a spade. I think every car should have one because it's the first thing. Digging a few holes is really important, and also looking at either a penetrometer, or even just if you have an iron bar with a T-piece on the end, will tell you a lot. You can dig a few holes around the field, and then you can have a look at what those holes are telling you. If you were to put an iron bar next to the soil, then you can go on a journey around that field very quickly, seeing, is the compaction layer in the same area? Is it a plough pan? Is it near the surface? It will tell you a lot in a very quick time. You know, doing lots of VES scores over a field may well give you more detailed information, but it will take a lot longer. So there are some tricks in the trade to get a feel of whether you need to go into a field and spend a lot on cultivations and machineries, but you can also find out where you need to set that machinery. The other thing to bear in mind is when to monitor. So, you know, the field on the right there, which is showing the picture on the right there, showing the beans there, you know, it's quite wet there. It's quite difficult to do soil structure tests and soil evaluations when it's really wet. You know, the field on the picture on the left there is probably is really showing a soil at the right conditions. It's off a grass field as well, so nice worms in there, good soil structure, very easy to pull apart. So I would say making sure that when you're looking and evaluating your soil, you're doing it at the right time. And sometimes that's quite difficult. If it's too wet, no good. And also when it's too dry as well. Too dry and all the water's gone, it's baked up. Sometimes people say, oh, that's a very compacted field. Well, actually, it might be just extremely dry. So, you know, when the soil is, you know, in early autumn or just as you get it going from spring to summer, the soils are in the right, because soil moisture content can really affect how you can make your decision making. So just a key point about that. And the same would go for when you're taking your organic matter tests as well. Take them at a time, in the right time in your rotation, similar time in your rotation. And also we can't forget our underground engineers, the earthworms, because they're really important as well. So, you know, there are several types that go surface to a bit more horizontal burrows in the soil, down to the deep burrows. They recycle nutrients. They break it down for some of the micro organisms in our soil. So they're really useful. You know, a rule of thumb is 16 worms in a spadeful of soil. That'll give you about 400 a meter square. It's quite easy to do. You can do it at the same time as you're perhaps doing a visual assessment of soil. And they're really, you know, if we can encourage earthworms, they bring air into our soil. They bring organic matter into the soil from the surface. Roots can follow it down, and they can open up that nutrient recycling. So really important as well. So how do we get this into something that's practical on the ground? Well, we can look at the AHDB scorecard. Would be a good place to start. You know, the AHDB have got some good information out there as well. So looking at soil organic matter, looking at pH, looking at P and K, which is probably standard practice. If soil organic matter isn't, it should be. But the things at the bottom there, the VES score, the visual evaluation of soil structure, and the earthworms in your pit, give you a really simple place to start as regards, rather than getting into too much of the detail around those tests around soil organic matter. And we're waiting at the moment with agri-environment schemes and environmental land management as to what metrics might be used in the future. I'd much rather see us taking some standard approaches to evaluating what our soil's like, and then rewarding practices, than I would do monitoring something which could be quite inaccurate, could be done by different farmers, different advisors, and could actually give us a clouded picture. So step 5 of my 6 steps is environmental land management, and I've just mentioned it. Is how can we use if you're on some fairly fertile soil and you've got good yields and good margins and everything's hunky-dory, probably might not be a step you want to take. However, if we're talking about sequestering carbon and we're using some of the environmental land managers, how can it help our soil as well? So using mid-tier, for example, which is in existence at the moment. So there's no crystal ball gazing for 5 years now, because there's a scheme already there. and ELMS will be developing, or ELM will be developing in the background. And we brought that in Loddington to try and bring it much more from around our field margins to much more in the field. So this, the one with the sheep on that you can see in front of you, has got us building up organic matter, fertility, structure, a whole host of things, recycling those nutrients. But so you can add things like cover crops in there, you can add herbal lays in there, and you can perhaps buffer some of your water courses and perhaps deal with some of your headlands as well. So a good way to use environmental land management to take some of that business risk management and also take out some of those lower yielding areas, which are often right next to the habitats that we need for biodiversity. Step 6, and the final one, really is agronomy and crop input approaches, the bio world I've called it. This is a companion crop we've got on the farm at the moment. The way we deal with our approaches to crop inputs will be interesting going forward. There's a lot of talk about consultations on urea and nitrates and things like integrated pest management. How we're using those processes. And I think if there's one thing that will come in a lot more, integrated pest management will have a lot more area for exploration in the future for looking after our soils. And I do think that whatever we're advising in the future, carbon and integrated pest management will have a big role to play. So I think I've been talking about regenerative agriculture a little bit, and this might be a follow on when you talk about the sustainable system in the future, Greg. So rotation, soil cover, reduced cultivations, grass with or without livestock, because it doesn't have to have livestock. But the final thing was about a systems change. If you only change one or two of those things, you're unlikely to get the benefits that we're talking about. And I think this is a mindset change, not just for farmers in practice on the ground, but also for policy. It's all very well having aspirations about how environmentally friendly we want to be, but we have to have incentives from government as well. If we want to have this regenerative system, let's make sure that we have policies in place and schemes that work, and make sure that we're not undermined with trade from elsewhere. My 6 points, and I'll just put them up there and leave them up there for a minute, is sort of my 6 steps, Greg, to where we're going to be with what we're dealing with from drainage all the way up to structure and monitoring, using agri-environment schemes, our crop inputs. And really, the one thing I would say is rotation would be the other thing that will help you a lot. And like Iain, we have a number of courses on either soil or on conservation management. We'd be delighted to see you. And without further ado, I'll hand back to you, Greg.
Sorry, everyone, I am here. I'm just trying to sort my screens out. I've got too many screens going on. So yeah, thanks both Iain and Phil. I thought they were such interesting talks, and they match so well, talking about the practical and the scientific aspects of kind of soil management. And Phil and Iain have stolen my thunder a bit, because I wanted to talk about how basis qualifications work with soil management, but they've already kind of highlighted that. And like I say, Phil and Iain are both basis training providers for some of our courses. But the 4 courses that really touch on soil management are the facts course. Even though it focuses on kind of crop nutrition, it really covers the fundamentals of soil management and how nutrition within the soil impacts crop growth. We've got the soil and water course, which looks at kind of soil management and the movement of water within that. So whether that's drainage, like Phil's been talking about, irrigation systems, preventing soil erosion, and all aspects like that. And then we've got 2 courses that are specifically focused on soils. Firstly, we have the Foundation in Soils course, which kind of does what it says on the tin, provides a foundation into soil management. And then finally, we've got the Advanced Quality of Soils course that Iain spoke about earlier. And yeah, that looks at the really advanced, takes some of the things that both Phil and Iain have spoken about today and covers it in real detail, looking at all aspects of kind of the soil world. So the microbiology, soil management, organic matter, soil structure and soil texture, and really goes into a lot of detail on that. So I've got quite a few questions. I know I said we'd try and finish by past, so we've only got probably 10 minutes to answer some questions. So if Phil and Iain are both there, are you happy for me to fire some across to you? Perfect. I'm going to start with Iain, and I'm going to pick and choose. We've had quite a few questions, so I'm going to kind of pick and choose some of the ones that we've had. And well, someone talking about raising organic matter on sandy soils. They've spoken about their experience of they've only managed to raise it by, well, not I say only, they've managed to raise their organic matter by 0.25% over 5 years, even if they've been using grazed grassland and fodder crops and lots of manures. What is the potential on sandy soils, and is there a limit?
So an upper limit, yeah. I mean, what was it, 0.25 or 0.5?
Yeah, 0.25% over 5 years. On a
really sandy soil, that's probably pretty good. I think there was work done on it was called the Woburn experiment, where they looked at long-term incorporation of grass lays and stuff like that on a sandy soil, and over long term you were getting increases. So it was important to increase it, but it was around that sort of orders of magnitude, because there's only a certain point where sands can hold enough organic matter because they're quite an oxidative environment anyway. So if we're still using them we are using them for agricultural production, they can't protect the carbon like a clay soil that can build better aggregates, but also has a more complex environment. So yes, they have a maximum kind of carrying capacity. It all depends on how sandy it is. If it's a sandy loam, loamy sand, but that's not from what I've seen. But I'm not a practitioner. I've just seen the studies. That is going all right, but I just don't know the upper level that they'd get to. It also depends if they've just started building it, or if they're at the end of building it from an already okay position for a sandy soil.
Yeah, that's really interesting. I think a lot of sandland farmers also types offer kind of challenges, don't they? And I think kind of it's a really interesting point. That's a great answer. But yeah, I think if they could be happy with 0.25% over 5 years, then I think that's at least it's a positive way, isn't it? So I've got a question for Phil now, and it's kind of on the practical sides of kind of maintaining carbon. So when you've got grassland in the rotation, so whether you want to reseed grassland, or that's what the question specifically asked, but I also think kind of establishing cereals or other crops after grassland, when you've got grassland in the rotation, what's the best way to do it to maintain carbon levels in the soil? Because obviously a lot of people traditionally would have ploughed up grassland and then drilled into it. What's the best method for doing that?
Well, you're right. It's a real conundrum, because obviously grass is quite a fine, small seed. It likes seed soil contact to get it established. You know, if your seed bed is too coarse, then you're perhaps not going to get quite as good establishment. So, and depending on the sort of soil you've got, ploughing and power harrowing and disking, etc., or some cultivations, there are more cultivations actually going to start releasing and oxidizing some of that carbon that's been in there from previous crops as well. But I think establishing grass is often to try and do as minimal as possible. Reseeding grass, if you can, direct seeding into it is quite a good way as well. And coming out of it is, have you got the right drill to drill into that grass sward? So, you may well decide to do a low disturbance subsoil and then drill straight into it. So you've dealt with the problem. But once again, I'd go into the field and dig. Go into the field and dig and see, have you got a problem anywhere in the soil? If not, can you direct drill into that field or over sow? That's probably the way to look at it. But I realize on different sorts of soil that might be easier said than done, and for establishment that might be an issue as well.
Yeah, always a challenge. And when I was working as an agronomist, I used to find that a challenge, advising on that as well. So I'm going to go back to Iain now, and you mentioned in your kind of presentation about compost being such a fantastic, stable source of carbon. But we've had one question: is if you've got a waste, are you better to apply it directly to the soil, or are you better to compost it yourself and then apply it as a compost? Because obviously you'll lose some carbon in the composting process, or will you lose more carbon when you apply it directly to the land? And I know I have seen a few people kind of composting farmyard manure almost. What's your kind of opinion on that?
I won't comment on like the waste regulation side of things, but from a sort of scientific point of incorporating it. But in terms of whether you compost it first or put it in the soil, so composting it first will will probably lead to a bigger increase in that, a quicker journey towards the stable carbon, but then you're putting it in the soil. If you just applied it first, you're probably going to get more losses because it depends on how you incorporate it. But you're right. If composting itself is a stable form, there has been a release from the start. But in composting, you're actually providing all the best environments to get it to that stable form, but there's less protection. So there's a bit of a waffly answer there. Yeah, it depends on the waste type as well.
So I'm going to have one final question. I think actually both of you will probably have an opinion on this, and I think we always knew something about cover crops would come up at some point. So firstly, for Iain, kind of, someone's asked, you spoke about carbon sequestration. Is there any way you could work out how much carbon is sequestered into the soil from growing a cover crop?
Yes, but you get into, if you really wanted to know, you'd get into quite a technical kind of measuring. I mean, Phil touched on it. What do you want to measure? What do you measure? And you could work out how much of it's decomposed and end up at that stable carbon pool. But there's quite a lot of different methods for doing that. What I would look at with cover crops is you've got two aspects really. You've got their incorporation and building of carbon, which is one aspect, and really that's only starting to get looked at in this country, and I'd anticipate studies coming out sooner, where we look at that long-term building of more carbon from incorporation of cover crops. But the roots themselves of cover crops, looking at different cover crop roots and how much biomass they can actually get into the soil is another aspect of it. But actually measuring it wouldn't be a quick fix, but you could do it.
Yeah,
lots of equipment.
No, it's interesting because I think you've got to look at cover crops a little bit about their multifunctional nature as well. So whilst there may well be some soil organic matter additions, it's more of a part of a system change that actually you're feeding the soil along with some other things like maybe grass and organic additions through your rotation. So you're looking at fertility and structure benefits as well as erosion benefits potentially. And we're now moving into, and Iain touched on it, we're moving into the realms of soil biological activity as well. So depending on what the crop is, so if you've got a lot of vetches in there, they're quite easily high in protein, soil microbes are made up of that, they like that as their diet. You know, the more digestible the muck is, the quicker the bugs get into it. So I think, you know, we've been doing some work with green tea and red tea, and basically green tea is all leafy and it breaks down really quick. The red tea is the more woody stuff. I think if you're looking at building there, you probably need to look at maybe crops that stay in a bit longer and have a bit more woody substantialness to them, so they'll stay in the soil and won't break down so much. So that's sort of my 1 minute 30 answer on it. It's much more in depth than that, but you know, it's not just the cover crop, multi benefits, and also whatever else breaks it down.
Perfect. Well, I said, as it said on the kind of invite for this, we're going to try and end at past. So I know a few more of you asked some questions, and I'm sorry that we've not managed to get around to all of them today, but I think if we kept having questions going, we could be here until 5 o'clock, unfortunately. So yeah, I just want to say thanks everyone for attending. I'm just going to move my slide on one slide. If anyone has got any needs any more information or from BASIS, then please visit our website, which can be shown on there, or drop me an email. And I'm sure if you've got any specific questions you want to ask Iain or Phil, if you drop me an email, then I'd be more than happy to pass them on, and I'm sure they'll come up with some interesting answers. And I also just want to say thanks again to Phil and Iain for speaking today, and I hope you all enjoyed it. So we'll see you in the next webinar in January, hopefully.